So I seem to be 3 minutes slightly delayed, and I'm not going to accept the blame for that. So I will continue slightly longer in spite of what I ought to do. I'm told that I have to curtail this talk to 45 minutes, so I'm going to set my timer here now to ring at 40 minutes, and I will try to keep on track. There we go. Just 1 second. I was not told until 2 seconds ago that it was 45 minutes and not an hour. Start. So I'll just tell you my name. First name, Bryn. Last name is pronounced Llewellyn, but we needn't worry about that. Bryn is enough. And I work at Oracle headquarters, and I am the outward face of PLSQL, and as it happens, edition-based redefinition. I can't present with a spotlight in my face. Right, so the first question before I start, just so that I've got a rough idea of to whom I'm talking, who has typed up some PLSQL in the last 2, 3, 4 weeks? Okay, I won't go any further because it's a multi-interest conference. I was rather hoping I might get people here who have no daily experience of PLSQL and wanted to think about things differently, but let's just check. Is there anyone here who knows, don't be embarrassed, who has hardly touched PLSQL and doesn't know anything about it? Okay, one, right, well, good luck, but I'll just focus the talk in the normal fashion. So the first thing I should say is this talk is really the sequel in a series, or at least the next episode in a series of talks I've been doing. And the general idea is to re-emphasize the way of thinking that used to be common a long time ago. So in that sense, the basic ideas are not novel. In other words, the idea that you should use the Oracle database as it was designed to be used. And that's a polite way of saying, don't treat it as just a bag of loose tables and possibly indexes, but certainly not constraints, because you read on the back of a cornflakes packet that constraints are evil. And I've been in conversations in the past day with people who insist that that's the right way to work so that they can put all the code in the middle tier and vendor independence, everything. So just to give you some material, if you want to spread that message, this is the briefest thing I could do. So, there we are. I even did a deliberate typo. I didn't bother to go SQL, just Bryn PLSQ. I'm flattered and lucky to find that that takes you, I'll learn this in a minute, takes you to that. The top hit is the PLSQL and edition-based redefinition blog. I also look after that. We won't mention that today. It's an Oracle blog site, and it takes you only a moment to come to here, which is the whole summary of everything that goes before this. And then, in particular, there's a movie which includes, among other things, a recording of a conference. I just have to stand near the computer. Of a conference presentation. Here we are, this thing, which gives the basic introduction of thought to all this lot. So, without further ado, and especially with only 45 minutes, I can only focus on today's story. And just for those of you who've never heard any of this thinking, that previous work basically was an appeal to common sense, the basic notions of modular program construction, and it emphasized in particular that if you've got a complex system with an Oracle database in it and other things, then clearly the Oracle database is a module, among other modules. Everyone wants to hide the implementation details in a module behind its API, and this talk is all about doing just that, hiding everything that implements the API from all sight of people who are connecting to the Oracle database from the outside world. The exact opposite of spraying naked insert, update, delete, and so on at the tables, where the whole knowledge of the implementation in the Oracle database is spread among different modules. Right then, moving on. In this session, my aim is to show you in practical detail how to ensure that you have a real impenetrable encapsulation, not just an API, but that you can't get in, can't get past it and see anything inside. I'm going to advocate strict adherence to this principle of least privilege. Let's not discuss why people agree that that's a proper approach. I'm just going to show you how you can construct all this lot in obeyance to that principle. And some of the notions that I'll talk about include code-based access control. Now, I don't know if you know about this, so I'm going to take a sidestep from the main presentation and just check. Code-based access control is the name of a feature that came new to PLSQL in Oracle Database 12.1, and its basic idea, you can use it in different ways, but this is the way I'll talk about it today, is to insist that every single PLSQL unit in your whole system, spread among however many different schemas you want, is invokers' rights. And that the outside world executes the small subset of subprograms, that's the API, by connecting to yet another schema, connecting as another user, which user owns literally no objects and has no privileges except what comes through public, and execute on exactly and only the subprograms who define the API. That's the basic model. Now, you would think that if every PLSQL unit in that system is invokers' rights, and the executing user has only execute privileges on the API subprograms, then at runtime, when the SQL happened, it would fail because it has no privilege. And as I've set it up so far, of course, that's the outcome. So code-based access control lets you grant, after you've created it, a role to a PLSQL unit, such that then, at runtime, the SQL that executes anywhere in that whole system runs under the privileges of that role. Now, has anyone heard about that? Okay, only 2 or 3. It's a key concept in this whole proposition. It's a key part of modern PLSQL. Anti-PLSQL people are always complaining that PLSQL is an old-fashioned language. That notion is relatively new, not that new, 5 years old, and it is without parallel in any other programming approach. And yet, the purpose, when there's an Oracle database in the picture, is to program SQL against objects in the Oracle database. So this is something not only you should know and understand, but preach to the people who insist that the proper place for code is outside of the database. That's a crazy mindset. So I'm going to rely on that notion. I don't think I will have any time to talk about a few other things that fit into that picture. We shall see. This part here, I'll do the best I can in the limited time. It's something people don't normally talk about. And the basic assumption behind every demo that you see is that everything that's installed that becomes the back-end of the application is installed by scripts running as something like sys or system. You know, that's what you kind of deduce from what you see, because no one talks about how to install stuff when you have stuff spread across many schemas. So there we are. And I will say something about error handling, not error handling in the large, but error handling exactly so that you don't leak out information to the client side about the internals of the implementation. So then, moving on, there was something at the bottom, and I don't think I'll have time for it. So this, I'm asking if you remember it. First question is, has anybody read a white paper that I've published on that blog called Why Use PLSQL? 1, okay. Well, you won't remember it then. I'll just show you that this was the way I talked about what we could call, in the light of this morning's keynote, an architecture for arranging stuff within the Oracle database, that set of artifacts that's your application backend. And there I said, put all the tables in one schema, put all the PLSQL code in another schema, and have that empty connect schema that I talked about, everything I said before. Now that was a sort of mixture of two ideas. You sometimes have to be a bit unclear in only 45 minutes. And what I'm doing there about two ideas, the main idea is the pink ring, which contains nothing, but is the endpoints, you could say, of the execute privilege on a small set of specially chosen subprograms, okay? And everything else is in a different schema. That's one idea. So to communicate that major idea, all I need is the pink ring and stuff inside it. Why have I got two? Why have I got the data in one and the code in another? Really, just as a hint that in any scheme, you're going to benefit from classifying things in the same way that when you put your photographs and your accounts and who knows what on your laptop, you naturally fall into some system of classification, files and files within files and so on. We don't have hierarchical schemas in Oracle database, but we at least have schemas, and so we're using them to materialize some notion of classification. I didn't have time then to talk about it. That's more the focus of today's talk. And the final point of this lot is, once you've established that hard shell, then all sorts of things can connect in the modern way. And this is the fashion that we're interested in at the moment, of course. So then, this is just another way of summarizing that whole major way of thinking. We ensure, by everything that I said before, that the only thing a client that can connect to the database, knowing the password and username that it knows, is do an anonymous block who invokes one or other of a small set of designed subprograms. As simple as that. Thank you so much for finding that. And that means, because that was the whitelist, and the whitelist includes things, and you don't bother to talk about what it doesn't include, but we notice it doesn't include insert, update, delete, and commit. Ergo, we understand that those statements, the guts of what happens, the implementation details, can only come out of PLSQL code. And unashamedly, a part of this whole approach, we are not doing auto-generation of SQL statements from some object model in some middle tier, resulting in the typical outcome of single row, single table statements. Rather, ordinary human beings who understand data modeling and the SQL notions and the mathematical notions behind SQL, formal logic and set theory, and obviously who can write if then else in PLSQL, they do all that completely ordinarily and as a result of proper intellectual effort by brain power. So then, let me show you an elaboration on that first diagram. So now we're coming from the outside in. Don't know if you've heard of this book, famous novel science fiction from the 1800s period by a French author, Jules Verne. So moving on, that is meant to represent now our opportunity for going back in time to clear thinking, which clear thinking fell from fashion. Everything these days in software engineering is driven by fashion, not common sense. But the fashion of the moment helps us because there's armies, truckloads of young programmers leaving various establishments of further education who've studied JavaScript and want to get jobs writing JavaScript. And these days, JavaScript and the execution environment for it in a browser is so rich that it's possible to implement these so-called single-page applications, which means that when something happens, the amount of traffic up and down and the amount of work to redraw the screen is minimal, right? It's not like the old days where the whole thing that you saw on the screen was computed somewhere else and sent over the network. Not that at all. And if you remember this way of talking about things, MVC, Model View Controller, in the fashionable period of the, what's the best word for it? All this Java stuff in the middle tier, that J2EE and on and on and on. There, the database was a bag of tables. All that Model View Controller, MVC, was in that middle tier, and the browser just got the complete representation of all the pages. Right? Now we have an opportunity to put the view and the controller. The view is all the stuff where they're painting the screen. The controller is, when I press this, what happens next? All that implemented directly in the hands of the end user by code that admittedly is shipped up, but that's the modern way. And that leaves only the M, the model, and we can put the model in the database. Ergo, these many programmers whose interest is to do rich UIs, do the V and the C perfectly, not care about the M, have what they want. All they want to do is ultimately paint a screen, gather some facts, send those facts off, and get the result back. The result, if the idea was to do some changes in persisted data, is yes, that went okay. Maybe the facts that were gathered were instructions on how to fetch information, in which case the result is a new screen painted with all that information. Sometimes the control side puts those two ideas together. I'm going to change something, and then the business wants to show the new state of the world all in one go. That's how these people think. All they want to do is call a REST service in the modern way, encode in JSON what they are saying, get some JSON coming back, and deal with it. Notably then, in this paradigm, they don't care about those diamonds. Those diamonds are the endpoints. They could be on thousands of different computers, well, not thousands, tens of different computers all over the world. These people doing that part don't care. This is where we come in. So that gray box is the encapsulation of the Oracle database. And all it is, as I mentioned, is an empty schema, and it's one of such schemas, and they're the only schemas that these outside of the database clients are allowed to know about. And all that they can do, as mentioned, is invoke PLSQL subprograms. And in now our second level of detail of explaining this, then what we see with the white dots is a particular kind of PLSQL subprogram. It's always a function, and its formal parameter is a single text data type that takes JSON in. And its return is a text type whose content is JSON. And these people here, the architects on this side and the architects of this agree on the set of operations that should be done, what they're going to be called, and how they will be parameterized in and out in a JSON representation. Then the two teams go off independently. Each of the sides can be stubbed up. The database team, notably, can do everything using SQL Plus as their test harness, because there's such a crisp delineation of interests between UI painting and everything about the business logic. So then, moving on, I am suggesting now that we regard that as a shim, just a little layer of protocol translation, and go into the real PLSQL. Now, what do I mean by that? Before I even go there, just pay close attention to this. This is a piece whose functionality is simply take an HTTP request whose payload is a JSON document and translate it into an Oracle Net request to execute a PLSQL function whose input actual is a JSON, and then get that JSON back and send that back as the HTTP return, okay? In other words, this component here is absolutely agnostic about the application semantics and therefore needs no maintenance. And that's another huge benefit of this approach. And I should say, in case you don't know already, it's called the ORDS, the Oracle REST Data Services subsystem. Okay then, now back to these boxes here. The blue box is just one-for-one, same named procedures as those functions. They could be procedures or functions, and they are parameterized using conventional data types in the PLSQL world. Whatever suits you. Booleans, if that helps you. In particular, indexed by PLSQL tables of records, which represent row sets going in or coming out of the database. Okay? They could be more elaborate. You know, a record, some of whose fields are scalars, and another of whose fields is itself a table of records representing the result of some master detail query. Okay? And why have the PLSQL conventional parameterization and only then the JSON in, JSON out as a shim? Exactly because there's always other kinds of client, batch programs, other kinds of robotic things, who don't want to bother with the JSON. They are perfectly well served by the conventional parameterization. Okay? Now comes the real work of implementation. I'm not going to choose a particular example to talk about and not give you any detail on that, but the idea of separating these things out is exactly to be crystal clear about what is doing what, okay? And in particular then, this set of objects here and those, I've described the JSON ones as functions, and I've described the next lot as functions or procedures, whichever is appropriate. I do not mean that they are schema level ones. Rather, I mean they are singleton subprograms in a package. In other words, I mean that the package spec exposes exactly one item, namely that. Why that fussiness? Because when you have the execute privilege on a PLSQL unit, you also can read its source code. That's a bit of a stupid historical design, but we've got it. It is what it is. You don't want anyone in the outside world to read anything about the implementation, even if it's a trivial pass-through to another named function, because at the very least, it'll start to give out information about schema names inside the database. So rather, we capitalize on the fact that when a user has execute privilege on a package, it can read the source code in the spec, but not in the body. Okay? It's a relatively small point in how much energy it takes to explain it, but it's huge in this whole security picture, because you do not want the outside world to know anything that it doesn't need to know, because that kind of thing can be exploited. Now, the pink thing, the real guts of the implementation, there you use different organizing principles. By all means, have many subprograms exposed in those specs of those things, and by all means have many code schemas where you distribute things according to your model of what's appropriate in that application. And then finally, the data, maybe one, maybe several schemas, again, according to your notions of what makes sense in your particular problem domain. And we will find, as we think about it, that there will need to be an error handling subsystem, and it's as well to draw it out for itself. And notice here, I'm in a sense saying we can manage that task with no more than a single table to record all the errors and a single package to do all the administration. And why not have them in the same schema? It's like sometimes if you've just got one photograph and one little document that describes what you did when you were there, it's silly putting them each on their own separate file system directory. You know, you make those decisions on the fly using common sense. If someone wanted to insist that that error handler should be in two schemas, it's their decision. Okay, moving on. Just again to talk about this JSON shim. Why have it? As I said, because that's the modern style. JSON in, JSON out is what the client coding who's doing the V and the C wants to talk about. And that's what it would look like, right? Actuals and return. And here now I'm saying that we don't want the outside world to be troubled by concerns that are not its. So if we get any kind of unexpected error, completely unexpected error, the sort you catch in an others handler, we don't want that to escape as an error. Rather, we want to communicate the fact that something terrible happened and you'd better report this in the ordinary world of how JSON parameterizes things. So that's one of the principal duties of this JSON shim, the basic translation from a JSON representation of facts to a PLSQL data type representation of the same semantic content. That's one. And the other is to translate actual Oracle errors and stop them bubbling out to the outside world and communicate what the error communicates in ordinary JSON. Okay? And the final bit of this, why not delegate that to the ORDS? You may have heard people giving talks on how everything can be automatically generated, blah, blah, blah. One point is enough. It's about control. You want the people who are exposing the API that delivers the JSON in, JSON out, including the composition of error messages, you want the task to do that properly to be in the hands of a single authority. Because after all, responsibility to get it right needs authority. And once the authority for a critical task is spread between different teams or different entities in an architecture, you're screwed. Okay? It's as simple as that. That's one way of looking at it. Philosophically, a good illustration of the kind of thing I'm talking about is the famous index by PLS integer table of record, which, as you know, is a concrete thing in PLSQL, which is an instance of the general notion of associative arrays in computer science. And what's an associative array? It's a key whose value has semantic importance and the payload, whose value clearly has semantic importance. What's a row set as a result of a query? It's no more than that, with typically an order imposed, but there is no key, right? Now, a faithful representation of a index by PLS integer table of record would include the key in the JSON. But we don't want that. We know what we're doing. We know what purpose we're meeting. Therefore, we want the control to do it right. If there was a robot for doing this, the robot would have to just follow the basic rules and encode extraneous information that then the UI would have to peel off again. And clearly, that's just stupid. So moving on then, error handling. This is a slight digression to stuff which I hope you would know inside out. At the basic level, if you consider something like selecting a row, a single row, it's your plan to select a single row from a table. In PLSQL, you use the select into construct, right? There are three possible outcomes. You happily get a row, right? You're offering up a value of some unique column or column lists. Or you get too many rows. Or you get no data found. And both too many rows and no data found are at that literal plumbing level Oracle errors with different numbers. But in your application semantics, they're completely different animals. Because too many rows from a table which has a unique constraint and where you offer up one of those values of what's unique to get something can't give two or more rows unless somebody screwed up, right? Dropped an index or something because some performance expert came and they said, oh, you don't need that index. And someone else forgot about its principal purpose of enforcing a constraint, okay? In other words, that's a completely unexpected error and there's no sane way to go on, right? That's one kind of semantic outcome. But the other one, no rows or no data found, that's just an ordinary outcome because the key that you offered up was done with a typo, right? I'm looking for myself in the information system and I forget that I've got two L's at the beginning and I put only one, no data found. It's not an error, is it? It's just an outcome which is communicated at the bottom level as an error. So your PLSQL code has to do the right thing and that has to flow all the way up. Okay then. And what you want is that the JSON encodes either no such employee or something which is very semantically specific, not just no data found, but in this end user terms, no such employee or whatever it might be, yes? No such purchase order. On the other hand, this is the maximum you can say. You know, oh dear me, there seems to be a completely unexpected problem. Here is the incident number, and please contact support or the mythical non-existent system administrator, right? That's the maximum you can communicate, because anything else you've said gives the bad guys information to hack. This is a well-known principle. I'm not inventing it. I'm only referring to it and showing you how you achieve it in this architecture. Okay, then, and just an illustration, even Oracle staff with an internet-facing application forget that principle, right? That's just in French as it happens, but it's the error you get when, it must be this, you're compiling a programmatically composed anonymous block at runtime. Who knows why they're doing that? Obviously, because they regard the Oracle database as a bag of tables and their complete architecture is wrong. Right, moving on. Expected errors, this would be one example. You catch it right at the source, and if it's, unique constraint violated, a different example. This is you're signing up for Twitter for the first time. You offer up your obvious preferred name, and the message comes back, I'm sorry, that handle is taken. So what we do there, if this was a real thing, a table of nicknames, or a table where one of the column was the nickname, you would catch that dupe val on index, you would check that it really was the index who implements the constraint that you have in mind, and then you would translate that into something to shoot to the very top by raising a user-defined error, user-defined exception, who in 12.2 can have a name as long as you please. So I'm not embarrassed about writing all that lot there. And then at the top level, someone translates that into the JSON. Okay, then. Just a note. Sorry. For simple, clean code, I'm recommending you never, ever, ever have an others handler anywhere except at the very top skin. Okay? Of course, you get less information that way. At the very top, you can get some information. And my claim is that that's 80% of what you need. And your code is super clean if you do that. However, some people insist on catching everything possible unexpected locally and logging who knows what, which can be logged. Okay? I'm not saying that's bad. I'm only noticing that that's doing a ton of work to get the remaining 20% of benefit. But if that's what you want, be my guest. Moving on. So what do we do in these jackets? I'm just revising this now. The jacket, which is expressed in PLSQL data types, has these tasks: act as a straight pass-through to the real implementation in yet another schema. Why? Because this way, that's where the singleton comes in. And as we'll later see, that's our granularity for this code-based access control. Okay? And then the other thing is to definitely be the one place where commit is issued in this whole system, if it happens to be an operation that changes data. Okay? There have been lots of fatuous, wrong tweeting discussions about this topic, but clearly someone must commit sometime, and there has to be a place where it happens. It cannot happen outside the database, because then you've lost the authority to deliver your responsibility. It must therefore happen at the very top level, the top skin. And that's the responsibility of this PLSQL thing, to do the commit. And also to do the rollback explicitly if an unexpected error happens. Now, some people don't bother with that in the different picture because they know that if a top-level call terminates with an unhandled error, Oracle does a rollback for you. But we're not going to do that here, because at the next skin, we're going to turn an error, any error, into a JSON encoding thing and never end with an error. So we have to own the rollback too. Is that clear? I hope so. Okay, then. The other thing, then, is that this is the unique location of the others handler when you're going for the clean code approach. The others handler discovers the actual error and the facts about it. It discovers the trace, what we call the backtrace, down to the spot where it happened. It encodes all that in some suitable representation. It inserts it into an error logging table in an autonomous transaction. It gets a surrogate key, the next value of a surrogate key back, and that's what it hands up further. Okay? And at this layer, that's done by converting everything into an Aura 20,000, putting a little globally unique ID for the app in the text, and following that by text which is sufficient and terse to communicate to the next layer what happened. Okay, then. And that's just an example that there's no time to look at of how to do that. So moving on then, there's just a couple of examples of it. If it's a fatal error, then we just have the GUID, the globally unique ID, the fact that it's a fatal error, and the ticket incident, the incident ID. Or for this expected error, we simply translate the text of the identifier of the user-defined exception robotically, mechanically into ordinary plain text that we pass to the next layer. Very simple. And then that's just an example of what you might see. Let's not worry about that now. What you do in the JSON, as I've said, really, it's nothing other than a protocol translator plus or at least I should say, within the general idea of protocol translation, there's a special case of getting those ORA 20,000s. If it's an expected error, just taking the text that came in the 20,000, putting that into a suitable JSON message for the outside. If it's the other, same idea, putting it in some JSON representation of the fact that this was unexpected and that the ticket number is this. Okay. So this is going to be a challenge in the reduced time I have, but the basic idea here is this. You've got many schemas. This is about installing the app for the first time and patching it later. You've got many schemas. If you think it'll be easiest to have one user who has privileges to operate in all those schemas, the only way that can be done is if the privileges this user has among the set those any privileges, right? And various experts have demonstrated by various exploits that a user who has even a single any privilege can find a way to elevate it up and become essentially God. So we just can't do that. The only safe thing to do is to maintain the objects in a particular schema by logging on as the owner of that schema and relying only on ordinary system privileges, never a single any privilege. Okay? Now, we don't want, for the 95% case, any DDL to happen at runtime, right? It's not our intention. A normally implemented OLTP style app only does insert, update, delete, and select. Those are the only privileges that any SQL that executes at runtime should have. How do you get your installation done? Okay? The basic idea here is that each schema has the required privileges. Oh, no, that doesn't work, of course, because then they would be available at runtime. So rather, you grant the privilege set that is needed for each schema to do its maintenance to a password-protected role. And then the person who will maintain it knows the password both of the schema where things should happen and of the password-protected role. Notice when this is going on, only the session that enabled the role has the privileges. And if you're doing this with zero downtime, as you can with that other technology I represent, that's a key point, because you want the patching session to be able to do what it does, but you do not want the risk of who knows what, SQL injection, exploiting the ability that you can create procedures or tables in your schema and doing who knows what, okay? So there's more on the slides, but the only thing I can do now is skate on and get to this bit, the code-based access control. I already set the stage for it. The bell is going to ring in 1 minute 40, leaving me 5 minutes. Basically, I gave you the account, and it's a new in 12.1 feature. Once you've granted the role to that invokers rights object, and obviously it has to be a PLSQL unit of some kind, and in our thing, it's always a singleton package, then the privileges that the role has operate at execution time, right? Now, if you think, and that way we get clearly least privilege, because you design the privileges that you give to each role, because each subprogram in its package gets its own role. You design each set of privileges for exactly and only the task that that subprogram is supposed to do. Now, we don't have to debate if that's good or bad. That is, by definition, the principle of least privilege. And that is, by common consent, good, okay? So I'm showing you how to do the hugely acknowledged ordinary principle, do stuff with least privilege, in this regime. Okay? You need a code-based access control. Sorry, a code-based access control role, a CBAC role. Now then, if you think the idea is nice, and if you want a different way to understand it, you could think how life was in 11.2 before this came on, if you wanted to achieve this. And it's easy to see how you achieve it. Instead of putting all those singleton packages in one schema, which itself has no privilege, and using these roles, rather you put each of those API-defining singletons in its own schema, and you make it define as rights. And then, so that's 5 minutes left. I'll try to do this very carefully now, but I might just go on a tiny bit. Right, sorry, just 1 minute. So then, you could put each of these in its own schema and grant the privileges that are needed to that schema, making it and its class uniquely defined as rights. You see what I mean? It's simple conceptually. Anyone could do it. No one would do it in practice because it would be hard to manage it, right? But that's the concept that this new feature gives you. Right then, that was all that lot. All that lot. And now we'll just revise that diagram from the inside out, starting with the data, or many schemas for the data, according to how you think you should do it. Why? Because data is different from code, and you're materializing a classification scheme in a natural fashion. Okay? There is the code. Again, as many schemas of that kind as you please, I don't care. And you'll discover that to get the code to compile, you need to grant privileges to the schema, but they won't be operative at runtime because of how invokers rights works, right? That's just the rule you follow. This whole notion of roles never affects what's possible at compilation time. I'm sure you know that. So you'll just deal with that. Moving on, there's the API. Again, I've shown you this just to revise the idea. These guys are singleton procedures or functions, each, in other words, in its own dedicated package, and using a conventional PLSQL representation of the semantics of the formals and the output. Then there's the JSON. We've discussed it and exactly what its responsibilities are. Then there are the other guys who are going to be exposed for direct PLSQL style invocation from other kinds of client. And then there, we've realized now when we program this that we want to use declarations all over the place. White dot means invokers rights. A package who has only declarations in it doesn't even do SQL, so that it's unaffected by the distinction between invokers rights and definers rights. So it can and should be definers rights, okay? That means if you've got a data type, a subtype, or a type that you define in PLSQL that's useful throughout the system, like an index by PLS integer table of record, you can define it once and reference it everywhere, okay? And here, right, is the picture story of the CBAC roles. So each of these guys, or maybe these guys, according to finer point of your thinking, has its own role, which gives exactly and only the privileges that we need. There then is the completing the picture with the exposure of what you've decided to using the execute privileges to a user who owns no objects, okay? If you're wondering how you get away without dot qualifying everything with the owner's name, just remember that you can go alter session set current schema and then just use the bare names. How do you get that done? In a logon trigger. Who owns the logon trigger? Probably you could allow that as one object in that schema, or if you insisted, you could have it as a system trigger in a different schema with the appropriate privileges. Okay then, moving on further still, now we discover, we didn't see that detail before, that for various purposes, we'll have yet another schema, or user, I should say, another user who allows people who know its password to connect as the administrator of the overall system. For example, to read the error log and, consult it, do stuff with it, diagnose. Okay then, and there's the outside world as discussed, and there's the other part of the outside world as discussed. And before I go to the final slide in that series of builds, I'm just going to remind you that, as Ted Neward said this morning, an architecture just provides signposts but not guardrails. So everything I've shown you is the spirit of the thinking, not the fine detail. And it's up to you to do the fine detail in the task in hand. Okay? I thought that was a very powerful point. And it's the exact counter, it's the exact antidote to people who demand, give me the best practices, give me the recipe. Okay? So then, there we are completing the picture just so that you can see it all together. Okay? Make sense? Right. So then, this sadly has to fall off the list because of time. Pity. You can read the slides and maybe get an idea of what it's about and look it up in the docs, but there's nothing I can do about that. And now here comes the conclusion. I've now hit my exact 45 minutes, but I'm going to steal a bit more because this only takes a moment. The first thing concluded in this way, everything I said that set the stage for today's detail, it's that an application, the overall thing now, an application whose purpose is to persist and show data, it is just worthless, non-negotiably worthless, unless the data that it is to deal with is persisted and then retrieved correctly according to the functional spec. Okay? It's as simple as that. Well, how do you achieve that? Many people think they're going to achieve it, as in our architecture discussions yesterday, believe it or not, incredibly, by, we've got to have all the code outside the database. It never even occurs to them to think about privileges because they haven't got that mindset. Immediately, they're screwed with respect to that. Okay? Any casual connection to the database, given that they have to allow connection to do the task, can do anything unconstrained. And all the responsibility for the proper implementation of data rules and business rules, what needs to happen in what order, is owned outside of the database, yet it's the database's responsibility to do that right. That is clearly a broken model. Okay? How do you achieve it? Well, they invented the right way in the early 1990s. It's amazing that I'm saying this today, but there you have it. Protect your data inside a hard PLSQL shell. And you know what I mean by a hard shell now. That's what the whole story up to this was about. In other words, if you want another way to say it, select, insert, update, and delete, the stuff of the guts of the implementation comes only out of PLSQL. And this is the time-honored way. Now, today, I showed you that when you've done that, now you have the luxury of talking about security. If the whole thing is just bollocksed up, rubbish in, rubbish out, you're screwed already. If you've done that right, well, security matters too. Of course it matters. It's critically important. Next in line. And today I showed you how to do that. Now, different people would argue differently about the next point. The next point is that performance matters too. I'm just going to say as briefly as possible, when you use the architecture that I'm advocating, then all the processing that needs to be done to do with the whole world of business logic, data rules, and the actual persistence and retrieval is co-located at execution time on the processes that do the whole task. The other way, you're in, out, in, out, in, out, suffering from, believe it or not, losing all the cached stuff in the chips. So every time you come back in, you're re-establishing that cached stuff in the chips, everything to do with branch prediction, all that stuff. And basically, you're stealing half your CPU's power. So when these people say, take the business logic out of the database, because it'll save the database effort, and the database is the bottleneck and the most expensive thing for licenses, they're saying, and by the way, throttle the database CPU to half its normal rate, even though we're paying for it. That's clearly madness. And by the way, that's just the first piece of the whole explanation. The basic in-out, 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 going through all those levels of SQLnet is hugely less efficient than when the PLSQL in the same process does the SQL directly. Okay? And of course, the final point in that performance story is exactly that any of these outside of the database schemes whose either implicit or explicitly advertised goal is to save these poor developers the intellectual effort of learning some SQL, therefore to generate it, they tend to generate it as single row, single table SQLs. And to, believe it or not, do even things like joins and restriction in middle tier code. Crazy. And the real world performance team have shown in many concrete use cases where they've been called in to see what the performance problem is, that by re-implementing it in this hard shell style, and then by noticing how they can use ordinary set-based SQL ideas in a proper fashion, they can speed up response time on typical tasks by 3 or 2 orders of magnitude, 100x, 200x. That's huge, okay? And look at those videos and follow up on the collateral, and then you will get the full detail of that full story. Thank you for your attention.